Great intro for a talk that's about supercharging your JVM performance with Java, and especially on Spring Boot. So thank you, everyone, for joining us today. We're excited to share this talk. It's the first time that we are doing this talk in a face of a bigger audience. So welcome. I am Ana Maria Michalczano. I'm currently working as a developer advocate in the Java platform group at Oracle, meaning with the Java team. I am here to tell you about the Leyden perspective, and together with me is...
Hi, my name is Moritz. I work in the Spring engineering team at Broadcom. I work primarily on Spring Boot, and Startup Spring Rail is also the team I'm leading.
And we would like to start with a small question for you. So first of all, we're going to present some features today that work with JDK 25 as well. And we would like to ask, which Java version are you using? Is anybody here on Java 8? Can you please raise your hand if you're on Java 8? Maybe we persuade you today. So one hand, good. Two hands. Java 11? Yeah, a shy hand here. Java 17? OK, well done. Java 21? Even better. Wow, I'm going to ask this one. Java 25? Well done. We have a few hands there as well. Well, that's great. And I think we also want to ask, if you're using Spring Boot. Are you using Spring Boot? Yes.
OK, great.
Good. Now it's time to take over.
Cool. Shall we take a quick selfie?
OK.
Can we take an Eastern European smile? So like this.
I tried.
Thank you very much.
It's too funny. So go ahead.
OK, cool. So we are going to talk about Project Leyden, especially when deploying Spring Boot applications. And the goals for our talk today is we want to understand what is Project Leyden, what it does to boost the Java performance and the startup times. We want to demonstrate that how to do this with JDK 25. So everything you see here is possible with Java 25. And also with Spring Boot, because I'm from the Spring Boot team and I have Spring Boot knowledge. And we also want to learn techniques you can apply when doing this, because you need to do some training runs, and there are some techniques which you can then use. With that.
Yes. What I want to say is that, well, application performance is not something that is you're doing once and it stops there. It's an ongoing thing when you're working on an application that is still running. So as applications evolve over time, new features are added, libraries and frameworks change, workloads grow, and, well, infrastructure shifts. So what happened is that throughout time, we have observed that for Java applications, the startup and the warm-up was an issue because Java is highly dynamic. So hence, the goals of Project Leyden. Who has heard about Project Leyden? Can you please raise your hand? OK, so you know what the goals are. But historically, Java favored time to peak performance over fast startup and short warm-up. Because most initialization code that is run is done by interpreting bytecodes. And while the hotspot JVM profiles the application's behavior to figure out how is best to compile its code to native code, all this work can take a while. And once hotspot has done all that work, well, it can highly achieve competitive performance. So what together in the Java platform we try to do is to achieve better startup time and warm-up time by shifting computation earlier or later in time. And shifting computation, this is the trick, the basic trick of improving the startup and the warm-up for Java. We can shift some of that work earlier in time by doing some earlier in time when the application starts, or later when the application has warmed up, or, well, maybe never. So how to shift work earlier or later? Generally speaking, there are two approaches. First one would be to statically analyze what the program that is at build time, and then to figure out which work can be shifted. Or observe the program at their runtime in a training run. Now, in the big picture, what Project Leyden wants to do is to explore both approaches. But for now, there is no static analysis being done. We're relying more on training runs to gather observations dynamically. And what's with these training runs? What did they actually mean for us, the developers? What does this term mean? Well, training runs are a way of observing what an application is doing across different runs. So there are primarily two types of training runs. Well, with those at build time, which are the integration tests, and those at runtime, when the production workloads are there, right? So what we wanted to do is like more detail. We wanted to see how can we do that with Project Leyden in the JDK. And the first features that were belonging to Leyden reached out to JDK 24, where a three-phase workflow was proposed. The step one of the workflow was to do the training run. What that meant was to use that line of code to obtain an AOT configuration, meaning to record observations of how the application is working in action, like which classes does the application load or initializes, or which methods become hot. Results were stored in a configuration file that is here in blue. Then it came the assembly phase, where we convert those observations into a ahead-of-time cache, the app.aot that's there in orange. And then step 3, obviously, we profit of that at runtime. And we run the application with the AOT cache. Now, to those of you that are familiar with class data sharing, CDS, that kind of is a little bit familiar as well in terms of working. But does this time shifting work? Let's look at some results. So these were the performance improvements that were the benchmarks that were run against JDK 24. Now, on the big pile we took as a reference, like the 1000, the JDK 24 mainline. Then the blue pile is the JDK 24 with AOT Cache enabled in terms of performance. And the green pile is the first early access build of Leyden and what was there. And the difference is because, well, the early access build of Leyden contains more experiments, so it will be lightly improved. But what is important to see here is that there's a significant improvement in the startup of the applications. And if you're wondering what applications were there, well, the first 4 are for different frameworks, are the hello worlds in different frameworks, right? And that's impressive, but they're hello worlds, right? So we also looked at the benchmarking performance for a more production-like application, and thanks for the Spring Boot Pad Clinic application, which is well coded, and we can take a look at it, that was benchmarked as well. Now, for Spring Boot Pad Clinic, we got great results as well, but if you're comparing the Hello World results with the Spring Boot Pad Clinic, you're going to say like, oh my God, but isn't that slower? Well, Spring Boot Pad Clinic is a real application, so it has more classes that it needs to compile at build time, right? So that's the reality. It takes slightly more compared to the Hello World, but it's still significantly better. So JDK 24 delivered the JEP 403, where the ahead-of-time class loading and linking was available. But we're having now JDK 25. So in JDK 25, we got 2 more in proposals that enhanced Leyden. So we can now improve the warm-up time of how our method execution is going by looking at the method execution profiles from a previous run of an application that was available when the hotspot Java virtual machine starts. And you don't need to add a flag to benefit about that in JDK 25. It's enough to use the AOT cache normally, like you used it before, and that is being done for you. Well, we also thought like, well, it would be great if like the workflow has 2 flavors. There's a 3-step workflow, and there's another type of workflow for those that are in a hurry or they don't need the 3 steps. Feedback was also received in order to like act upon it. So that was another enhancement about improving the command line ergonomics of the JEP. So the last JDK enhancement proposal, 514, transformed the workflow into a 2-phase one. And in the 2-phase one, what you have to do, well, you have the training run and assembly phase 2 in 1. You just have to use the configuration of AOT cache output. You get the AOT cache. And then, of course, so one mistake there. And then we can use the deployment run of our there in the workflow. What results were there? So for JDK 25, we got even better results when we compared JDK 25 as the initialization of our comparisons, and then we looked at JDK 25 with AOT Cache enabled, and of course, there's another early access build of Leyden, an EA2 there, where we ran again how things are going on and how we evolved. So even better performance just with JDK 25, something that you can take advantage as well. Now, Leyden has delivered all these performance gains, but has done it in a way that makes it fully compatible with the specification of the Java platform. So what this means is that you don't have to go and recode your classes. You don't need to rewrite any of your code if you're on JDK 21, actually, because there were a lot of hands here. Shouldn't be that difficult to get to 25 and just use the flags and benefit of the performance. So with that in mind, let's take a look at how Spring Boot has made this better for you.
Cool. Thank you very much for explaining, Anna. So we are now talking about AOT Cache with Spring AOT, and everything you're going to see in the next slides, you can do that like now. Download JDK 25, it's GA. Download Spring Boot. 3.5 also works, but we are currently working on Spring Boot 4, which comes out in November, which of course supports that stuff, but you can already do that right now. Okay, so the first thing we're going to do here is I built a pet clinic. I upgraded the pet clinic to Spring Boot 4 to get JDK 25 support, essentially. And we are going to start it just like we've built it with Maven or Gradle, just with package or with build, and you got the Uber jar, the big one with all the dependencies in it, just to get a baseline, okay? And here we're going to start it. Type some commands, let it start, and you see this is a real application. There's Hibernate in it and stuff like that. It's doing stuff, and it's starting at like 3.3 seconds, okay? So that's our baseline. Like, this is what you get out of the box, and now we want to improve that stuff. Because 3.3 seconds, I mean, it's not that great. First thing, what do you need to do to benefit from the AOT cache? The first thing is you need to use the same JVM for the training run as then for the real run, where you use the AOT cache. That means you need the same architecture of your operating system, the same Java virtual machine, the same vendor, the same point release. Just use like the same virtual machine you use for training run, use them on your production. Otherwise, the cache may be invalidated. If the cache is invalidated, it still starts, it's just slower. So it doesn't crash and burn, it just starts slower. The second is a restriction on the class path. So the class path, it must be specified as a list of jars. You can't have any directories or wildcards in there. And that means you have to pre-process your Spring Boot application a little bit, because Spring Boot uses a custom class loader to support this Uber jar thingy. So where jars are inside jars. This is not a concept which JVM understands. So we had to write our own custom class loader, which then somehow knows how to deal with jars. And this is currently not Leyden compatible. So we have to extract that stuff. And the third thing is the class paths you're using at deployment time must be a superset of a training one, which are just complicated words for you can append stuff at the end of the class path, but do not fill with the rest of it. Otherwise, the cache may be invalidated and your stuff starts slower. And the last thing is, which can trip you off, is so the JVM needs a fast way to validate if the cache is still valid. And it does it by looking at timestamps and, I guess, file sizes at the jars. So if you copy those jars around, make sure that you preserve the timestamps. Otherwise, the JVM may think that the jar file has been changed, and then it invalidates the cache and your application starts slower. Okay, so those are the 3 steps. Use the same JVM, do not fiddle with the class path, and be careful when copying stuff around. The first thing we're going to do is we get rid of this Uber jar. Okay, there is this fat jar, which you get when you run Maven package or Gradle build, and you have to extract it. Fortunately, there is a jar mode inside your Spring Boot application, which you may have never known that there's in there, but every Spring Boot jar knows how to extract itself. And what it does, it flattens itself. So it's extracted. And what you do is you start it with a special mode. It's called jar mode tools, and then you point it to your Uber jar. This is the fat one. And then you call extract, and then you can give it also a destination directory. I call it extracted. And what you get then there is an extracted folder, and if you run tree on it and you see what's in there. There's also an application jar in there, another application jar, but this one is much, much smaller because it only contains your code and your resources. And then there's a lib folder, and then there are all the third-party dependencies your thing is depending on. So this is essentially the unpacked version of your Spring Boot fed jar. And this thing here, the application jar, it doesn't use the Spring Boot custom class loader. And it adheres to all the stuff I just said. It sets up the class path without directories and wildcards and stuff like this. So this is CDS compatible, this is AOT Cache compatible, and this is also like Leyden other stuff compatible. The funny thing is you don't need to use AOT Cache with that. You can just run it that way. Okay, let's see what happens. This is just Java 25, execute with the extracted version. The extracted version starts in 2.4 seconds. So only by extracting that stuff, getting rid of the custom class loader, you already shave off like 600 milliseconds. Okay, that's a neat little trick. If you decide after the talk you don't want an AOT cache for whatever reasons. I doubt it because AOT cache is great, but if you don't like it, you can use just the extract command. Okay. Now let's talk about the training runs. So Anna hinted that we need to do training runs, but what exactly is a training run? So there are two ways to do training runs. The first is the hard way, but like always in software engineering, there's a trade-off. The trade-off here is your training run is hard, but then you get like really good optimal performance. The way to do is either you run your integration tests, which of course have like close to 100% test coverage and cover all the stuff you do in production, or you mirror production traffic if your chief information security officer lets you do that. The idea is that you essentially put the same workload on your training run as you get in your production, because only then, like the whole AOT cache can collect profile information like it would in production. Or you can even create the cache in production and then just pull it down from the production service and use that for the next startup. It's possible too. The benefit is that it exercises like many or all hot code paths used in production, but it can't easily be done while building the image. The cool thing is it also collects the profiling information. So the JVM has run, it has like received production traffic or production-like traffic. It knows which methods are called how many times, and it can like store that stuff in the AOT cache. But the setup is more involved. And like if you're lazy, you can use that one. That one doesn't require any production traffic. It's stopping the application context before the refresh. So the refresh is a concept in Spring Framework before, like, you register all your beans, and then before you call refresh, it would create. After refresh, it would create the beans. But you can stop it before that. So it loads all the classes. It puts all the classes in the AOT cache. This is really easily be done. I'm showing that afterwards. It can be done by building the image. Absolutely no problem. It only caches class loading. And it doesn't collect profiling information because you have essentially not put load on your application. And it doesn't exercise all hot code path. So though, yeah, you had a question? Yeah, it depends on how many CPU cores you have. So until the JVM essentially decided to compile your stuff with the C2 compiler. So it depends on my benchmarks. On my 32-core machine, I reached it after 1.5 seconds. If I restrict it to one core, it took like 15 seconds. So yeah, could be. Then you have to do your training run for like 20 minutes. Yep. So it's essentially the same time until your JVM is hot. Yep. And the easy path doesn't exercise the hot code path. So you now have a trade-off. You use either the hard way and you got optimal performance, or you use the easy way and you don't get like that optimal performance, but it's still impressive. So let's talk about the easy way. We want to exit the application context before the refresh. And for that, you pass like the system property, which is called spring.context.exit.equals on refresh. And this instructs the Spring framework to just kill your application before application context refresh. And this works like this. You start your application. Spring Framework instantiates all your known lazy singletons. It calls the after properties set lifecycle methods, and then your application is shut down. Okay, so this makes sure it loads all the beans, it loads all the classes, and this stuff is then put in the AOT cache. And this stuff here, the lifecycle start and the context refresh event published, is not done. Okay, this is only done when running in production. We shut down at the red bubble. So let's see this. We create the AOT cache using this command. Using AOT cache output, we set Spring context exit on refresh, and we put it to our extracted jar file. And after this command has been run, so it exits automatically because Spring Framework shuts down the application before the refresh, you have an AOT cache, and this AOT cache here is like 53 megabytes in size. Okay, and this contains like loaded classes and some profiling information. And now you can run the application with this thingy. Just put it like remove the output from the first command, like it's only AOT cache, and then point it to the AOT cache and start it with the same jar, and then your application starts faster. So let's see that.
Okay, so it should be less than 2.4 seconds, right?
Yes, 2.4 seconds was our thing. Now it's 0.8 seconds.
Nice.
Right, so this is the startup. And remember, we haven't changed anything in our application. It's still using Hibernate and all that stuff behind the scenes. There's a question. Very same.
So the question was like, is this AOT file, and why does the AOT file need to use the same JVM? Is because there is, also for security reasons, there's created this connection between the two. So you don't want to you don't want to have the possibility to inject something through bytecode injection, since you're going to use this at the runtime. So that's why we are insisting a lot that the training and assembly phase to happen with these requirements. And I'm going to talk a little bit about that in the operational phase of the presentation. Very good question. Keep them coming.
Okay, so we are now down to 0.8 seconds just by doing exit context on refresh. Okay, so we shaved off like almost 2.5 seconds. Okay, so but startup time is not really like a good benchmark because that's not what you're optimizing for. You're usually optimizing for time to first request, right? This is the time span your application needs to really serve like your customer request, which makes you money. So that's what you're measuring here. And by using the Uber jar, you're serving the first request after 3.5 seconds. In the extracted form, you're serving it after 2.8 seconds. And if you enable AOT cache, you're serving it already after 1.1 seconds. Okay, all by only enabling JDK, the AOT cache. And this is not Leyden prototype stuff. This is JDK 25. You can download it right now and use it in production right now with your Spring Boot application only by doing the tricks I've just shown. And then you shaved off like 300% of your startup time. So like it starts up 300 times faster, 3 times faster, 300% faster, I should say. If you take a look at the RSS, so the RSS is the memory measured from outside of the JVM, so from the Linux system, operating system level. And there is a slightly like 70 megabytes less. And if you take a look at the user time and kernel time, this is a very interesting metric because this essentially tracks how much energy your CPU just used. How much time the kernel and the user land spent executing your stuff. You see that we started out by 16 seconds of CPU time burned, essentially, converted into heat and CO2 and whatever if you don't use renewable sources. We're down to like 7 seconds. Okay, this is like, we cut that stuff in half. That's really cool. And this is, of course, this is what your cloud provider builds you on, right? It doesn't build you on startup time. It builds you on consumed CPU seconds. So the lower you get, the more money you make. And you essentially do not destroy the planet if you use less. Okay, now we have to talk about AOT cache and Spring AOT, because maybe you have read in our documentation, oh man, there's Spring AOT. Why is there so many AOT stuff in there? There's AOT cache and Spring AOT and AOT compilation, and what is going on there? The AOT cache is something the Java team built. Okay, this is the JVM feature, and this is the one we have been talking about right now. But this is the successor of CDS, so class data sharing, and I talked about AOT cache is just the new name for it, and it's just better. And then there's also Spring AOT. And Spring AOT, the Spring team built that originally as support for the GraalVM native image. So if you're using GraalVM native images, this is like mandatory to enable the Spring AOT. The Spring AOT can also be used in a JVM to speed up that stuff anymore. And how it works is when your Spring application starts, it puts stuff in the application context. And by starting, it usually inspects like configuration classes, creating beans reflectively and stuff like that. And what Spring AOT is essentially doing, it takes a look at the application context and then it outputs code to restore that application context without calling reflective stuff. And this is faster because you can then compile that code and give it to the JVM, and it turns out the JVM is really fast at executing code. So that's what you get when you enable Spring AOT. It has some trade-offs. For example, it freezes your bean arrangement, but we are currently working on that one. You also get like cool features like Spring data repositories already pre-compiled and stuff like that. So this is another optimization we can enable on top. But you have to remember there's trade-offs like everywhere. In this case, there are some trade-offs like freezing bean arrangement. Please read our documentation for that. So it's not something you can just enable and then get it without any drawbacks. Let's do that. I passed spring.aot enabled in here, which enables the AOT mode, and then it starts in 0.6 seconds. Okay, so we shaved off another 200 milliseconds. And remember, we started from like 3.something seconds, and now we're down to 2.6 seconds. Taking a look at that, it shaves off another like 200 milliseconds. It shaves off a little bit of RSS, so it's almost 100 megabyte less RSS, which is quite cool. It's a fifth less. And it even uses less energy to execute stuff on your CPU. Now we are down to 5.4 seconds of execution. If we take a look at the requests per second, which is very interesting. So this thing here is the plain JDK 25 version. And we see that the JVM, so like the bar starts lower in, let me check the magic pointer. Okay, it's working. That's so great. Okay, this here is the time the JIT collects profiling information, and then it starts compiling code, and then this here is using the compiled code. Okay, this is when the C2 compiler has kicked in and produced optimal code. So this is the optimal throughput for your application. And it takes some time, of course. Anna said that the JDK 25 AOT cache already collects the profiling information in our training run. So I would expect, if I enable AOT cache, that this curve looks like lightly shifted to the left. And this is exactly what we're seeing. The JIT does not need to collect profiling information because it had already done so in our training run, and now it starts compiling stuff faster. That means the green bar reaches the peak performance faster, which means more throughput per second while starting up. Cool.
Okay.
And yeah, we talked a lot about all that stuff, and now Anna is going to show us how to do that stuff like really in production, how to get that done with like Docker.
Well,
hopeful.
I kept it only at the Docker file level, and the last example is the link to my experiments as an Negist, and actually I'm expecting more deployment ways to be asked about those by you at the end of the session, or to discuss more of those approaches. So these are just a few examples because I think we can make a session just on the operational approaches only. Let's revisit a bit the three phases. So we have training, assembly, and deployment, and we don't always see the assembly phase in the workflow. In 24, we had like 3 stages in the workflow. Now we can have 2-in-1 for the first 2. And then get to run. Now, the nice thing is that once you have an AOT cache, you can use that AOT cache in 1 deployment runs or more, which is great because you don't rebuild your AOT cache when you're scaling your applications, right? And we do need to scale and fast scale, especially in containerized applications. So let's look first what I wanted to inspect. So this is like a sequence diagram that I did for some of my Docker files. I started easy. I just wanted to build with JDK tools. I just used the plane from JDK 25 image that I have available, the OpenJDK 25, built at Oracle. And then I like to use glink to just get only the modules that my application is using. By the way, I still use SpringPad Clinic. So I like this part to just keep it simple. And if my modules change, because I don't know, I need to change time my application, or I need to add more tools, I just can give that as an argument to my Docker file and just pass it. And at build time, and it's fine. It's good. Then I built a minimal runtime. And then I got another argument with my jar file, and this is pretty much the workflow in general that I would use for any application, not necessarily Spring Boot. So these were the first phases that I had in my first Dockerfile stage, and then I moved to another Dockerfile stage where with the runtime that I had before, I did the training run and assembly phase with pretty much the command that I used in Java, but now I passed it to a run in Docker. And well, at the end, when I'm going to run my container image, I'm just going to say a command that does use the AOT cache stored somewhere. So this kind of approach is great because I can generate the cache at once and reuse it across multiple deployments because I'm just going to run it. And then I'm going to ensure that every container benefits from the same warm-up run throughout the time. Now, let's look at the Spring Boot situation because, well, I talked with Moritz and he said, hey, Anna, but for Spring Boot, it's better if you use the jar mode tools. So, oops. Not back. So in order to do that, I have just removed this one. So I've used again the my back or what?
It's this one. Yep.
Okay, this one. Okay, so you'd build a minimal runtime with in the first stage of my Docker file, I just gave the modules and the jar file, build the runtime, but I also extracted my jar because that's how Moritz taught me to do it. So good thing to collaborate with an expert and you get to understand what's going on. And then with these two things, I moved to the next stage. And in the next stage, I just did the same thing that I did before with training and assembly, and I kept the same. So this is great because I'm extracting the jar into dependencies, snapshot dependencies, Spring Boot Loader, and all these things. And this means that Docker only recopies what changes. So it's great for faster rebuilds, only when your application code changes.
Yeah, this uses a feature of the extract mode, which is called -- layers, and then it extracts like the dependencies in a layer and your own code in a layer because like the dependencies change a lot less than like your code does.
Nice, but I wanted to do it even better. So I was like, okay, but there are cases, you know, when people get from their provider already created, I don't know, GRE, a custom runtime, that already has a minimal set of modules and they don't have to care about that. So what they can do, they can use that and they just can be preoccupied of having that one and extracting to jar mode tools, and that's pretty much it, and running with that. Now, I mentioned, the question came earlier, like how close do we need to keep the same JVM and so on and so forth. In a multi-stage Docker file, I don't think you want to change in between one JDK and another one. You pretty much keep the same from in between the stages. I've never seen that happening. So you kind of, by the way, all the time, by best practices, you keep the same from. And on the other hand, on the second from that I have in my runner, I just need an operating system. Again, I'm aiming for a fast startup, peak time to fast time to peak performance, but I'm also aiming for a small container image in the end. So I want to have it all if possible. That is great because by separating this builder from runtime, what I got is that the container that is doing the building can have broader privileges for tools, and that's great, you know, for extracting tools. And then the runtime container is actually leaner. So this aligns very well with some known security thing that's called least privilege and immutable infrastructure practices that people do. So, and from scalability point of view, the generated app can be mounted and shared into many runtime containers. Amazing. But then I spoke with some folks and they said, hey, but we would like to save the AOT cache somewhere in a volume, for example. So we would like to separate these two in two different images. And I was great, let me try that as well. So you can also separate things in having two images, like one when you're building your runtime and you're extracting the jar. And then there's another one that gets that goes exactly and does the layer of just hosting that AOT cache. So you can do that thing as well, and like creating the AOT cache in one image, and then reuse the generated AOT cache from the persisted location. So what this gives you as an advantage, it can create an even slimmer runtime image if you have the base already created, and this is pretty cool. But I also gave like a few pointers here. It's great. And the thing is that, yeah, that's what I want to get. So the pointer that I want to say here is like when you are creating your AOT cache, because you just need the output of it, I would say not to keep that container. So that's why I'm saying that, hey, can remove it yourself at the end after you run it. Just want to keep the result of the AOT cache. So smaller container image is great, but don't forget to properly secure your volume. So pretty nice. You can host the mounted cache and just run with the mounted cache, and you can just point it there, docker run, deploy, and that's it. Same commands and so on and so forth. The link over there, we're going to share the slides, don't worry. Good. So what to be careful with? Cache validity and staleness. So app IoT depends on your exact application code, JDK version, modules. If you rebuild the app or upgrade your JDK, you must regenerate the app IoT that I had there. So otherwise, you risk crashes or undefined behavior coming from like methods missing from that cache. That's the problem. Then there's the question of portability that Moritz has talked about. Like you cannot build on your Mac and expect to run on a Windows, right? And then there's a more important part, like startup path coverage. So the training run usually covers the typical application startup path. So no cheating with those tests, because then you're going to cheat on your application performance. And of course, there comes the operational complexity. Well, it's up to you how you choose to share or to store the AOT cache, but be careful of which path you are taking, because there's no easy way to go forward from a security point of view. So without further ado, we want to talk about also what's next and share more performance. So what's next? Well, first of all, what's next with Project Leyden? There is currently a JDK enhancement proposal in draft mode, where we're looking into how we can address the ahead-of-time code compilation. So compiled code is not just generating and storing some code somewhere. There's a lot of compilation work that's going to handle transition between different tiers of the AOT code and the JIT. So what my colleagues try to address right now is actually the any remaining performance gaps that are between the AOT and the JIT code that need to be investigated and closed. But I think you already used the Leyden.
I did.
Yes, the EA2, the Early Access Build 2, to get some performance. So.
Right. So what I did is I cloned the Leyden repository from GitHub because it's all open source. I checked out the pre-main branch. I built the JDK myself.
It's not that tough.
No, it's not that tough. It's not. I mean, I got a Linux system running, so that was fine. There's a good README on it. It took some time because, I mean, it's compiling a lot of stuff, but I just grabbed a coffee and then I came back to a freshly built JDK, which was the Early Access 2 version of the Leyden prototype. And now we're going to run like our extracted application against this Leyden thingy. Okay, so we just pass AOT cache, and you see that's apps Leyden, but otherwise this Java is like the Leyden Java, and you see it starts now in 0.45 seconds.
Even better than you had before.
It's even better.
Okay, so
who would expect it?
Yeah, okay.
Okay, let's see what the time to first request says. So with AOT cache, which is JDK 25, and let me get the magic lighting thingy here. This is what you get in production right now. And this here is what you can expect if you take the prototype right now. It's 979 milliseconds, and then if you enable like Spring AOT on top with 770 milliseconds. We are down from 3.5 seconds to 775 milliseconds, and I did not change anything in my application. No cheating. It's still Hibernate. It's still like an H2 database, and it's still behaving like everything. This is like a startup performance of a factor of 5. I mean, you know how hard it is to get like a factor of maybe 10%, but this is like 500%. This is just crazy. The RSS also shrinks a bit, so we have like 380 megabytes at the end, and the user and kernel time. And I had to do this like 3 times because I wasn't trusting the numbers.
You couldn't believe that it's that good.
I mean, look at this. This is like 16 seconds of energy burned, and now we're like 1600 milliseconds. So essentially, we shaved it down by a factor of 10.
Wow.
Because like the Leyden thingy has already pre-compiled this code while building or while doing like the training run, and then it stored the pre-compiled code inside the AOT cache. And when I start the application, it maps the cache back in the memory, and then it uses that code. I mean, that's not bad. Okay, so here, factor 10, startup factor 5. Awesome. Let's take a request. The request per second, so we already remember the blue curve is JDK 25 without AOT cache. The green curve is JDK 25 with AOT cache. It has collected profiling information. And Anna said that the Leyden prototype, it also compiles code and stores it in the cache. So what I would expect is that the curve, the Leyden curve, starts even more on the left side. And what we see here is exactly what we predicted. I haven't predicted that gap, but let's talk about that later. But this one here,
it's still like some stuff are experimental.
Right. It's at so it starts faster. It reaches here peak performance faster because it already compiled code. And this gap here is something the Java team, I guess, will work on so that this yellow curve reaches this curve, so you don't have like any drawbacks when using Leyden. But as you can see, it starts up much faster with a higher throughput, and this proves that the code has been compiled before and just mapped into memory and has been used.
So more that we are looking into evolving when it comes to Leyden. There's a lot of work that is going on in that. But for Leyden itself, the portability is a priority. And there's a question that we need the help of folks that are running JDK 25 or will run JDK 25 in production and hopefully will use the features of Leyden to improve the startup time and time to peak performance of their application. And we want to have with your help to get the answer like should the AOT cache use the best possible instructions or just compile for a typical deployment target? Because the platform is there, but you are using it. So it's important to give feedback. And there's also another part that applies to other parts of the system. So there is a JDK enhancement proposal that's called ahead-of-time object caching with any garbage collector. For example, if you're trying these features with a Z garbage collector, you're not going to see the same performance as you see normally with a G1 garbage collector. So we're trying to close these gaps when it comes to portability, but also to extend the AOT capabilities to user-defined class loaders, because you told me that you kind of need that as well on the Spring side. So currently training runs are using only the 3 built-in class loaders. You have them in the parentheses there so that I'm not to go and identify them at all. And the class is loaded by them. But through community demand, user class loaders are used, and it would be great if they would benefit of the same performance improvements as the others are benefiting at the moment. So yes, give us feedback. Well, try the features, give us feedback, and we'll know how to evolve things even better. But so far, we're doing pretty good from what I've seen in your experiments as well.
I got a funny story about that graph here. So while creating the training run, I've created this Leyden AOT cache thingy with 32 CPUs because my workstation has like 32 CPUs. Right. And then I tried to use the Leyden AOT cache with which against the machine which was restricted to 1 CPU, and then the Leyden cache hasn't been used at all because the cache has been invalidated. And it turns out that if you run Java with 1 CPU, you get serial garbage collector, and if you run it with 32 GPUs, it switches to G1, which is the default garbage collector. And the Leyden cache, it also it contains like precompiled code, and this precompiled code has knowledge about the garbage collector. So you also have to make sure that this is like you do the training run on an equally like sized machine, or at least use the same flags that forces a GC and stuff like that, so that the cache is not invalidated. I mean, you see it when starting it. If it starts in 3 seconds, it has not been cached. If it starts like blazingly fast, it has been cached, right? But this is what happened while I was creating those benchmark numbers.
Yeah, but I mean, the worst case that it happens is that your cache won't be loaded and it will start the normal way, so that you doesn't crash the JVM, but you will not see the same startup. You're gonna spot it quite easily.
My workstation hasn't catch fire or something like that. Yeah.
Yeah.
There's a question.
Yeah.
Is there an impact when you run the training on your production flow or throughput, or is it just collecting metrics in the background and then when you exit it?
So the question was: is there an impact when you are when you're running the training runs on your productioners from what we gathered, there's minimal impact on your production workload. And I think the people at Netflix already use these features, and I think they're streaming well. So we didn't get any drawbacks, except for those cases when you forget to use the same flags, or you don't keep things in sync, or try to use ZGC and the gaps that are there. So to answer the question in general, no. Let's go.
Okay, let's talk about AOT improvements we have planned in the Spring framework, in the Spring projects like Spring Framework, Spring Boot, and other parts of the Spring portfolio. So what we are planning to do is we want to introduce modular Spring AOT, because as I have said, Spring AOT currently locks down your bean arrangement because it takes a snapshot of your Spring application and then codifies it essentially. And maybe you want to switch that off, but you want to benefit from the other parts of Spring AOT, for example, the predefined zglib proxies, the Spring Data AOT repositories, the pre-generator and stuff like that. So we have to find a way to that you can opt into the features you really want. So it's not like atomic switch on with all the drawbacks, but you can switch it on more fine-grained. We also want to pre-compute class path scanning. So those blue things here are links into the issue tracker. And we're going to investigate how to do that and when to do that. So no promises yet about release availability, but we are thinking about that. We also want to customize the condition evaluation, because one drawback of Spring AOT is that the add profile annotation doesn't work anymore, because you have to essentially specify the profile while building the application when running Spring AOT, because it codifies your bean arrangement, and add profile affects that bean arrangement. And so we are looking at maybe we can support stuff like that when running on AOT too. Yeah, so this is currently planned. So we are hard working on that stuff. So you can expect more great performance gains in the future.
Well, what you can do today is actually to invest in training your application today, mostly to look at how your application behaves when you're running the training runs. Keep your JDK and your Spring Boot applications up to date with releases, because, as always, the latest releases bring the latest features and the best optimizations that are there. And of course, with each release, we hope that Leyden gets even better performance for you, and it delivers even more for you, and it will continue to stay fully Java platform compatible, so that you don't need to rewrite your code, your Java code. You just add flags, and miraculously starts faster and gets time to peak performance even faster. Without further ado, we want to thank you for listening to us. Do not forget to give us feedback, engage with us, asking us questions, and bring your problems to us. We're going to be around at the conference. I'm going to be at the Oracle booth, and you can stop by and ask more questions there. Looking forward to hearing from you and from what you have encountered when working with Project Leyden's features. Thank you.
Thank you very much.